This is our manufacturing and materials presentation we have for you today. And we are a 11th year team with 11 members. We've previously won every award in not at once, but in every tournament. And I'm Grant. I'm our build lead for this team. And we have
Sorry, I'm JT and I'm a builder on this team.
and we'll be the ones doing the presentation for you today. So we all these workshops, our purpose is to give you learnings from our experiences and to help give you a jump start into your season and give you tips and tricks that we've learned. And we're going to be talking to you about how manufacturing and materials incorporates with FTC. So we're going to start with the different types of manufacturing. There's two main types, and then there's a bunch of subcategories in there. But there's subtractive manufacturing and additive manufacturing. And first, we're going to go over subtractive manufacturing, which is the type that starts with a solid piece of material and then chips away, which this piece of material could be a giant plate, could be a block of material, could be whatever. And there are a few types of this. There's milling, there's electrical discharge machines, laser cutting, water cutting, grinding, and sandblasting. These are some of the main forms, and most of the ones that we're going to show you today are guided by computers called CNC machines, and they're all going to generate some type of waste material, some kind of shards that get shaved off, and they're most commonly located in machine shops and maker spaces. But there are some websites that will show you that you can export your ideas to and get them cut to and get them sent back to you for the season. So these are the few ones. I grouped them into some similar categories. I've got four main categories here. I'm going to start with milling. This starts with, instead of a plate, it starts with a whole block of material. And then you can see it uses a drill bit that slowly shaves away with the material using CNC, using some CAD file you have, and just slowly shaves away at it. It can cut through any length of material as long as you have the right drill bit that'll cut deep enough. It can cut through it. The machine costs on this one are generally less than all the other ones, but still expensive. And material costs are higher than other ones because you do have a giant block instead of a plate. So getting that block made and sent out to you is a lot more expensive than just buying a plate. Next up, we have the electrical discharge machines. Instead of using some physical form of cutting away, it uses electricity to cut away the metal piece by piece and uses water to allow that current to connect with the metal. And from there, it cuts off that metal. It is repeatedly sparking it, and so that's what makes it cut off the metal just through repeated sparks over and over again. And then this one, as long as you have a big enough bath of water or a water stream, it can cut through any material as well. And it doesn't need any physical contact with the machine other than it being submerged in water. These ones are also on the lighter ends, but still more expensive than other ones at $30,000 to $60,000 per machine. So these are two of the main ways. Now we're going to get into probably the more common ones that you see, which is laser cutting and water jet cutting. These are very common. They're slowly emerging through FTC. Instead of using a block, these use a plate of material. And so that makes your cost be lower for material. And so they use either high energy lasers or high pressure water jets to cut through the material. And they obviously do it in an enclosed space. The majority of the time is in an enclosed space so that it doesn't harm anyone while it's cutting. But the problem with this is you have your material length is limited by the strength of your laser or jet. That's why they use sheets instead of blocks because it can't cut all the way through those blocks. And then these machines are probably the more expensive ones, but they are more widely used and on a bigger scale than other ones before. And then finally, we have grinding and sandblasting. These are probably more types of finishes than starts of projects. So this is what you do when you want to clean your project up, make it look nice, smooth all the edges around. It uses most of the time pre-made parts to give that nice finish on them. And then it uses abrased or excuse me, uses jagged or abrased edges along with high speeds to cut away at the material. So it can either be using like a circular saw you see in this first image here, or it can just be blowing sand at a high velocity towards your object, so it'll slowly move away any rough edges and start to smooth that out. And then these can be used for a lot wider range of materials. It's not as limited as all the other ones would be. It can be basically any type of material that you would think of. And then these ones are the cheapest of them all. And then, of course, you can always use your trusty sandpaper or file that you have in your room if you want to save a lot of money and just start doing it yourself. Won't be as clean, but it will still be nicer. And so this is what we use for outsourcing designs. This is a lot cheaper way than to actually buying a machine and manufacture and keeping up with everything and manufacturing yourself. It's helpful for getting custom designs in a way that you don't need to buy the machine, but it does take more time than you actually getting the machine. Obviously, it would take more time because they have to ship it out and then get it back to you as well. And these are the two websites that we go to. There's CNC Madness, that's one of them. These take a lot or a bit longer of a time because they're located further away than we are, but they still give you quality parts in a timely manner. I think they come in about 2 to 3 weeks it takes for them once you get your file sent out to them to get it back. And then the other one, which is very similar, is Send Cut Sent. It uses metal. This is basically the same thing as CNC, but instead it's a lot quicker. And I believe it has a lot higher variety of different plastics or metals that you can use. And they get it back to you in about a week turnout, but it does become more expensive than using CNC Madness, especially when you get into the higher quality parts. So that was all of subtractive manufacturing. And now we're going to go into additive manufacturing, which is the other end of the spectrum. Instead of taking away from material, it adds to it. This is great for rapid prototyping and testing and generating a small amount of waste compared to subtractive. And then the three main forms that we're going to go over today is material extrusion, which is commonly associated with 3D printing. There's powder bed fusion, and then there's vat photopolymerization. These are big words, but they're very simple in concept. So we're going to start with the most common one, material extrusion, or commonly known as 3D printing. It's super accessible and it's very common. It's basically everywhere now. When you look up 3D printing, this is what first pops up. So what it does, it slowly layers lines of plastic called filament on top of each other to form any shape that you have. And it's a lot faster than most other methods as it's a lot cheaper, more viable. So it'll be on a lot smaller scale too. So with that smaller scale, it's a lot quicker to have your parts be turned out. And then it's easily modified and upgradable. So each printer you can have is a lot easier to change out parts or upgrade different parts so that it works with more materials than if you were with any other machine. And it's super user friendly. There's such a strong community out there for almost any 3D printer brand that you choose. And they're really inexpensive, especially nowadays. Some companies are selling a good quality printer for around 300, $350. It's super viable now. Next up, we have powder bed fusion. Instead of using lines of filament, this uses a very fine powder and then a very precise laser to melt those powders together to form shapes. These powders can come in a lot wider array of materials, so it won't just be plastics. You can also have metals as well. And then it creates parts in higher definition and strength without need for supports. So unlike material extrusion, this doesn't need support since it has that powder layered on top of each other. You don't need to waste material on supports. However, these machines are more commonly expensive as the wider array of materials requires a higher demand on the 3D sorry on the powder bed fusion itself. So everything on there would be a lot higher quality, but it's also a lot more expensive because of that. The last one we have is called photopolymerization. It's a lot simpler than it sounds. It uses plastic in there, liquid plastic, and then uses UV rays to harden it to form a shape. Very similar to material extrusion, except it's basically the opposite way. Instead of having a strand of plastic, you have a big pool, and then it basically shoots rays of lights at it to harden it up and to make a project or make a design. It's a lot smaller compared to the other ones. So on these, you have a lot smaller scale and a lot smaller turnout. And there's less material options. So it's not many rubber. There's not many harder plastics. It's all often rubbers. And there's a post-treatment required to it to strengthen the plastic so it doesn't fall apart. But in turnout, it's probably a lot quicker than all the other ones. And you can get a lot higher quality parts than material extrusion or powder bed. And these are also fairly cheap nowadays as well. So next we're going to talk about 3D printed sources. If you wanted to start something in your school, what would be a good way to do with this? There's two main brands that I like to use, and that's Prusa and Bamboo Labs. These two are the ones I use just because the software is the easiest and they have really good printers overall. And then the way I'm going about it, if I wanted to start incorporating this into my school or my designs, is you want to start with smaller printers. Most companies, most brands offer a mini version of their printer so you can go off with, and you can start learning about how the printers work and how the software works and everything. And then once you get into those mini printers, you start moving into the regular size printers to where you can start adding a whole bunch of these. These work great over time. Um, that's really easy to swap on and off plastics. Everything's real simple about it, but you don't get as high a speed or precision, or you don't have an enclosed structure. That enclosed structure is important because when you print some plastics, you have to research if printing that plastic can create toxic fumes. Most of them won't, but there is a very few amount of plastics that can create toxic fumes, and so you would want to watch out for that in case you started printing and then you accidentally print a plastic that creates toxic fumes, which wouldn't be a safe environment. So along with researching that, that's why enclosed printers are better in enclosing that environment, making sure no one breathes in those fumes. But if you don't plan on using any special materials like that, regular printers are perfectly fine. All the materials we'll show you today shouldn't create any toxic fumes. So if you want to go with any of these, that'd be great. All right, and then that should be all it for this first one. Any questions for this yet?
Yeah, Grant, you must be just hitting everybody's questions as you're going.
All right, that's great then. I'm gonna keep going. Once again, any questions, just throw them in the chat at any time, and we'll get to them as soon as possible. All right, now we're gonna start getting to the more precise stuff about materials that we often use or that we see around. So we're gonna start with one of the more common ones. This is aluminum, specifically T6 aluminum. T6 is just the grade of aluminum. Most aluminum works fine, but the higher the grade you have, the higher the quality your parts will be. So these are very lightweight, very versatile, very easy maintainable. These can be used for a variety of different parts, whether it be from structural to actually engaging with parts or game elements in the field. This is probably one of the most versatile ones, and it's super easy to work with and make new holes and soften the edges around. But this is definitely the weakest of all the metals, and it bends a lot more easily compared to all the other ones that we're going to show later on. And over time, all that bending it does will wear down the metal itself so that it becomes less strength, it has less strength when you go on. But this is the most common material used for metals and manufacturers like Gobelda and Rev. All their structural supports that I know of, at least, all their main structural supports are made out of aluminum just because of the cheap cost and the structure it brings as a metal. Next up, we got is titanium. This is a very, very high strength for its weight. It's super lightweight, but it's also super, super high strength. This is why it's used in aerospace and also used in obviously the new iPhone. They made a big deal out of that, but it's very high strength for its weight, and it can take heat very, very well. So as it gets heated up, it's very, very hard for it to get melted down. But since titanium has a lot higher strength, it's also a lot higher cost and machining difficulty that comes with the cost as well. Because to cut through this, you would need a harder bit to, or a harder tool bit, which requires a higher cost as well. And it's a lot brittle. So although it has a very high strength, it doesn't absorb impacts well. So it doesn't like to bend at all. Instead of bending, it just straight up snaps. So that's why it's a lot harder to maintain over time and a lot more brittle than other metals. And then last up, we have a special type of steel. This is called AR500 steel. It is definitely the strongest metal of all of them. It has a very high impact resistance and great resistance to wear. These are used in shooting range targets. I personally use this for combat robotics. These are super, super high strength. Even though they are a lot heavier than other ones, if used in the right applications, it'll give you tremendous strength. And that strength also comes with machining difficulty, just like titanium. And it's very, very heavy. So unlike titanium, which has a high strength for its weight, this just has a general high strength, not worrying about the weight. And it's a lot denser than other materials and expensive, which also includes into the cost. And then next up, we got JT with plastic materials.
So the first plastic in the few that we use this year is PLA. It's very cheap. It's very abundant. It's probably the most used 3D printed plastic. Um, really easy to print. It is somewhat weak. It's very moisture sensitive, which if you leave it out um, and don't dehydrate it using a dehydrator, the print quality will be affected, and then it also degrades in sunlight. So same thing. If you leave it out in the sun too long, the print quality will go down. And then what we used it this year, we used it for quick prototyping, such as our claw arms to make sure we had the design the way we wanted it to be. And then we also could have used it for some of our decorative parts. The next one is PETG. It's a lot stronger than PLA. It has a little bit of flex, but it's a lot stronger. Same thing, moisture sensitive, and then it can also scratch really easy. We use this for our end claw designs, our slide brackets, and our arm casing mechanism. TPU is highly flexible, impact resistant. It's almost like rubber. It is pretty difficult to print. Same thing about being moisture sensitive, and then it's harder to print in detail with this. And then we use this year for blocks to stop our pivot from going too far back, so we wouldn't compromise our center of balance. And then HDPE is really durable, low water absorption, lightweight. It's not 3D printable. It is pretty difficult to cut, and then it degrades the quality of the plastic in sunlight. We use this year for our side panels, which helped protect our robot from any impacts. And we also have acrylic, which is clear, easily cut, and also rigid. It is brittle, so it can crack really easily or shatter. It's prone to scratches. You'll be able to tell because it's clear. Doesn't bend very much, and then it's also not 3D printable. We use this for our original hang mechanism prototypes, and then we switched over to aluminum.
And now then last we have carbon fiber. This is probably one of the greater strengths of plastics. It's super stiff, it's super wear resistant, it has a great strength overall, but that strength comes at a price, especially for plastic. So it is very expensive, being expensive than a lot of metals as well. It's also difficult to manufacture. With all that strength, it's conductive as well. So if you have some open leads on your robot and you have that touching this carbon fiber, it can cause a short in your system, which cuts out your robot. And it's also not 3D printable. These have to be cut out of material. And then you can use this for any support structure, any protective cover, kind of like main supports for your robot. You can use it for side panels. You can use this for covering for your wheels. It's very versatile for its high strength as well. All right, we got another quick question break. Once again, any questions, you can put it in the chat anytime. We'll try to get to you as quickly as possible. Wait here for a few minutes and then we'll go on.
Hi, this is Andrew. I'm actually starting a rookie team. I've been part of FLL for years, but we're finally starting up an FTC team. Question for you is the materials that you're presenting, like the metallic materials and the plastic materials, are those just materials that you use personally, or are those the like sanctioned materials with First?
These are the ones that we specifically use. Most teams use pre-manufactured parts, so like GoBuilda and Rev. So especially if you're
Correct.
starting out, they have a lot of great stuff you can start out with. But this is more if you're going into like that advanced for like a design reward, let's say for an example. You want to go to the higher limit and you want to understand how each material works. So instead of just going with aluminum every time, you can variate that with a different type of metal that would suit your needs better for this year. So this is more specifically geared towards what we would do and what we would recommend for each part, rather than being towards what other teams use.
Okay. I only ask because I do a lot of 3D printing with work, and I know a lot of different materials, and I just again maybe they're more expensive materials, but
Yeah.
I just wanted to make sure that these weren't just the only sanctioned materials you could use. They're just what you guys have experience with.
No, this is just what we have experience with. Anything that you think that works great, go ahead and go for it. This is just if you have no idea, it's just what we would think we would be best to start off with.
Good to know. Thank you very much.
Yeah.
Grant, you want to touch on where you might find some of these maybe a little more obscure materials that you just can't buy off of Amazon as easily?
Yeah, so using the websites we have earlier, CNC Madness, Senketsen, those are great for a lot of the non-3D burnable plastics. So that AR500, that carbon fiber, the acrylic, HDPE, aluminum, and titanium. Those are all places you can, the website we showed earlier, those will have all those materials on it. So you have any design, you can get it cut out from there and then get it shipped back to you within about a week or two. And that's one place you can get a lot of those non-3D printable ones.
What
Some
was the
places,
website again, real quick?
it was the materials or the websites.
The website.
One of them is CNC Madness, and the other one is Send Cut Send.
Okay.
So those would be the two that we often use that gives us the best quality and turnaround time. And then for the 3D printable ones, one brand I like to go to is Sane Smart, just because of their wide variety and their good quality of plastics. And of course, any plastic is fine. It's when you get into the more expensive ones that you want to be for sure that you want to get this type of plastic. So pretty much any type of PLA or PETG, those would be fine, any brand. But when you get into the higher ones, even TPU would be fine. But if you want to worry about your quality, you would want to get a definitely higher bedded plastic. So Sane Smart is the company that we often use for our TPU and our other plastics.
One of the other things, and Grant can expand upon this a little bit more, that we did for Connect was we looked around locally for a plastics distributor and reached out to them to learn about some of the different options and what they may have. And they have continued to support us and provide us with materials when we need it as well. So you may look around in your community for something similar. Grant, if you have any additional words you want to say around that too.
That's also a great way for doing outreach as well. Not only is it a great way to get engaged with your community, it's a good way to get parts for the season, and you could put it in portfolio. So you can say, we discussed and got parts from this company, and then from there you can point to on your robot saying, yeah, we got this part from this company, and they're one of our sponsors, or they're one of the people who we go to when we need a part. So not only is it great for your robot, but it's also great for your presentation and portfolio as well.
And I think Coach Matt from Team Emerald asking, where did you get the non-3D printable plastic parts? Hopefully that answered your question. If it didn't, please, you can turn off your mic and, ask maybe a more specific.
Yep. All right.
I got a thumbs up, so.
All right. I think we're good to go on then. We'll have more question breaks as well. So anything else that pops up, let us know. Now we're going to get into the more complicated parts, composites. This is definitely where you want to get engaged with your community because there's a lot less sources online compared to finding it with your community as well. So composites, they're made up of multiple materials instead of one at a time. And then some examples of these are more basic ones. Fiber reinforced, particulate, laminar, and sandwich. These are just the names of the composites. This has nothing to do with what they're made of. And then, so this is for combining different materials together, whether it be metals and plastics, different plastics, different metal, whatever it may be. Composites are just a combination of all those combined together. And so this can lead to greater strengths in your parts, but it can also lead to greater weaknesses if you don't have the right knowledge or mindset of how you combine these two different materials or parts together. So we're going to the first one, fiber reinforced. This is just using fibers of one type of plastic and then covering it all in another one. This is very design flexible, so as long as you make your design fibers the right length, you can make this design customizable to how you want it to be. It's not, you don't need much maintenance on it because once you make the part, that's it. You don't have to worry about it. You've already made the part. You don't have to upkeep it. And obviously, it will result in a higher strength as long as you do it with the right materials because it'll combine the strengths together and it should give you a high impact resistance in many ways, in many different forces. So whether it be compression or torsion, it should help present against those forces. But obviously, composites are more expensive than normal ones because you have to combine the cost of both of them, and then you have to worry about manufacturing them, and then repairing them is a lot more difficult than a metal piece because it's a composite. It's made up of different materials, and you can't just slap on one material. You have to try to work your way around it, and often places it's better to replace that part instead of trying to fix it. And then they're also brittle, so they also like to snap away instead of bending. Next up, we have particulate. We're going back to Saint Smart as our example for this one. They have a carbon fiber nylon. This is a combination of carbon fiber and nylon filament together. It's a lot cheaper than other forms, and it gives you a very uniform strength. So in every way, since the materials are so bound together, it's a very uniform strength in every force, and it's very wear resistant over time. But it's probably one of the more weaker ones because of that uniform strength. It's all spread out instead of focused on one area, and it's more brittle. It's kind of like how PLA is compared to PETG. It's very brittle, and it doesn't have a super high flex. So the impacts are going to be straight up absorbed, or it's going to be straight up taken and won't be absorbed at all. I would be careful about this filament. I think this is the only one where it does create toxic fumes. Yeah, I believe this one creates toxic fumes. So if you want to do this, be careful. Make sure you have a good airflow. But if you want to do this, go ahead for it. Next up, we have laminar. This is just sheets of plastic stacked on top of each other to create a composite. This gives you a very high strength and a very high flexibility, and it's super easily designed. You just stack materials on top of each other, but it's very hard to repair since those materials are stacked up onto each other. So you have to get through different layers, replace that one layer or how many layers were damaged, and then add it to the original part you have. And then since there's so many different sheets of plastics, it creates a higher cost. And then quality dependent is just basically quality materials will help you keep the quality of your strength better. This also does have a directional strength. So instead of having a uniform strength all around against all forces, it's mostly impact resistant. So straight on forces from its face instead of the sides is what it's best at. If you go at the sides, it's very easy to peel apart instead of just going for the top piece. And last but not least, probably the easiest one to make a sandwich. It's just two different materials on the outside of one main material. It can be anything you want. It's very energy absorbent, easily customizable, so you can easily change out which materials you wear. And it's super lightweight. So instead of having multiple sheets stacked on top of each other, you can just have one material, be the lighter one, be on your inside, and then the ones on the outside can be heavier ones, which is a lot lighter, but it still gives you a lot of the properties of both of them. This also has that directional strength where it's great for forces head on, but taking a force from its side is not the best for it. And it has a lot lower impact resistance than all the other ones from its sides as well. And then we're going to go over I think this is our last part, is just use cases for the materials that we all just went over. There's a lot of them. So we're going to show you our designs for our robot this year and how we would use them for our designs. Yeah. So we're going to start off with plastics. This is our drive chain from this year and our robot from last year. We're going to start out with the TPU. This is our drive chain for this year. The TPU is currently covering our pulleys that we have on the inside so that anything that tries to get into those pulleys will be stopped by the TPU. And the TPU will absorb a lot of the impact it takes and push it outside as well. So it won't break and fall into it. It'll just absorb the impact and send it right back out. Next up, PETG. This is the one that we used for our claw arms this season. We liked it because of its rigidity for grabbing the samples this last year. It was very strong. It had a very good grip on it, but it could also take some hits from other robots, or if we accidentally ran into something, it would most of the time be able to survive the impacts as long as it wasn't every force acting against it. It's not invincible, but it's a lot stronger than PLA, which is our next one. PLA. This is just a decorative piece we had in our robot, and we used it for prototyping a lot of our early plastic designs, but mostly in the end, we just use it for decorative pieces. Next up, same robots, we have metals. Aluminum we like to use all through our robot because we like the strength of metal, but we also want that lightweight. So aluminum is a good compromise for it. That's why a lot of companies use it. This year and last year, we used it for a lot of our structural pieces that we wanted to keep light and that it didn't super matter about the strength. We just want it to be nice and rigid. So all these white pieces are our structural parts. These keep our robot held together. It's kind of like their glue. It keeps all the parts nice and together, and it keeps a high strength, allowing everything to stay uniform within there. And also, aluminum also used a lot of low stress applications compared to our next one, which is AR500 steel. It was a lot heavier, so we used it for our pivot slides this year. We had a lot of weight on the base of our robot, and we wanted to make sure that it didn't snap. So we would have used AR500 steel for that if we didn't want to worry about our weight, and because it has a super high strength for it. Last up, we're going to go over some composites. We're planning on using it this year, but the previous year we didn't do it. We used HDPE for our side places previous year, but we could have used a sandwich. We've used that years in past where we had, I believe it was titanium on the outside and carbon fiber in the middle for a sandwich design. That's one of our favorite ones to go to. It's probably one of the better ones because titanium keeps its form well, and the carbon fiber on the inside can also help absorb that impact more. And then we also have particulate. This is our battery mount that we're planning to use this year, and we want to make sure that won't break mid-season by anyone attacking it. So we would probably use a lot stronger of a plastic if we could to keep its rigidity and to make sure it doesn't flex around. All right, so that's all that we've got today. We're going to stick around a bit if you have any questions, but feel free to contact us with any questions you have this year through our Discord, through social media, whatever it is. We can take any questions. This is our Twitter, Instagram, and email. And then we have one more upcoming workshop. I believe it's just our programming one, which is, I think, in 2 weeks. Someone can correct me on that if I'm wrong, but I believe it's 2 weeks from now. Thank you all for showing up. We really appreciate it. We'll have one more workshop later on.
Okay, here's a question from Colin. For subtractive manufacturing, what materials would you suggest to use for each machine?
I'm gonna go back to that slide real quick just to refresh on that. Subtractive manufacturing machines. Okay. All right, here we are. So for each machine, what I would use, it really depends on what your machine can do. So each machine, you want to look at the materials and strength it can go up to. But I'm showing one of the more common ones for each one and what I have experience with. For milling, it's most types of metals. Obviously, the higher strength ones would be harder. You need a lot stronger drill bit, but it can go up to basically any metal that you have, whether it be aluminum or steel. I believe it can do all types of those, as long as you have a hard enough drill bit. EDMs are the only one I'm not sure about. They're my ones I have the least familiarity with, just because I haven't used them that much. So I would definitely look for that if you're planning to use that. It's definitely one of the more unique types. I'm just not sure about those at all. But laser cutting and water jet cutting, those can do a lot of types of plastics, or a good amount of types of plastics, a lot of metals, and some wood as well, depending on if you get the right cutter. Once again, you gotta look at your specs for your machines, but these do a lot of different types of metals. You would need a higher end machine to start doing titanium and AR500. But for aluminum, metal, plastics, all that, those would be great for that. Then grinding and sandblasting, these are good for basically anything, any material you want to use it with. So it wouldn't matter if it's a plastic or a metal or composite. This can be used to finish any of them. It's great for that.
Just want to watch out with any kind of aerosol or breathable particles that come up if you're doing grinding and sandblasting. All of these, but particularly that one. Something, let's say, carbon fiber. You don't want to have carbon fiber dust coming up if you're not protected. You'd absolutely want to protect yourself.
Yeah, of course.
Yeah, I'd also add that I think there are very few teams that would have machines that would be in this category, at least in FTC. Um, but you may find in your area there may be like a manufacturing, like that you can join or be a part of, or where they may have some equipment, some machines that are like this. Um, and then the other option is Grant had mentioned earlier is even things that require milling, for example, there are companies online where you can send them your design and then have them send you back a part. And especially if you're just doing one or two parts, that may be the more economical way to go.
Yep,
Yep.
for sure.
We talked to Rick, you brought up right the makerspace or manufacturing kind of things. If you happen to be near a university, a lot of times if they've got an engineering or some style of like mechanics kind of program, they may have some of these machines that are available. It's worth looking into and seeing if you can turn not only in to upgrading your machine and or your robot and its capabilities, but also the connection to other groups. And there's a question here from Coach Matt at Team Emerald. How did you attach your TPU covers to the frame?
Oh, for that, I'm gonna go back to our picture, but I'll explain as we go. There's two ways that we're gonna do it. The way we're gonna do this year is we're gonna use some screw inserts for the plastic, and we're just gonna melt it in with a soldering iron. Or the other way you can go with it, you can just make solid cutout holes, and you can put some standoffs in there, so you can screw into the standoffs, and then that plastic should be secure in place and won't be able to move because of those standoffs in there. But the way we're going to do it this year, because we want that high strength and limited movement in the plastic, we're going to put in some screw inserts and melt that into the plastic.
Question from Colin. What design techniques would you recommend using for brainstorming for the robot design?
Not only design techniques, but materials I would use is anything you can find. So it can be the worst quality thing, but I'm going to assume for very simple brainstorming, you're going to want to use whatever you can find in whatever shape and form, as long as it looks similar to how you have it in your head. It'd be great for brainstorming. And then let's say you don't know anything about these fancy materials and you just want to get your first type of robot out there for the season. Using just manufactured stuff or pre-made parts like from GoBuild or Rev would be a great way to start the season, getting your whole team straight on how you want the robot to move forward. And then from there, you can go on to using these more advanced parts and materials.
Yeah, we've even seen in years gone by that cardboard is something that gets used for proof of concept in the early prototype phases, just to see how would this look, how does it X, Y, or Z, and then from there go on as Grant did. But I mean, when he says you can use anything available to you, we've used just about everything available to us.
Yep. Cardboard, duct tape, scissors, empty bottles, whatever you can find works. Just as long as you get your idea out there.
All right, great questions, Grant. If you want to close with showing the last slide where they can contact us again.
Yep.
And with that, thank you, everybody. And thanks to our build team for putting this together and presenting it today.